pressing the button. Okay, it looks like we are live. So hello everyone, this is Postgres TV Open Talks series where we invite selected speakers, selected talks. We select from the talks which others already selected. Like it's already good talks selected by some program committees of various conferences. And today we are going to talk about Postgres and Go. And our guest is Pavlo Golub from Cybertec. Hello, Pavlo.
Hey, hello. Thanks for having me.
Great. So thank you for joining. I know that it was quite challenging to find the proper time, and like I'm glad we finally making it. So let's if you can share screen and present our
let's try.
Slides. Yeah,
let's try. Can you see it?
Yeah, it's starting. Yeah, I see it. Good.
Yep. Cool. So okay. So my today's talk, I gave it a couple of times already. So it's just like overview of how one should start or how one should write the application in Go language and use it with the PostgreSQL. So probably for professionals, nothing new, but I mean for people who want to try these language, I hope that will be helpful. So my name is Pavlo Golub. I'm a senior consultant / developer at Cybertec. I'm more like developer. I don't really like this consultant part of my job, but yeah, it's fine. So a couple of words about my company. So we are a mostly remote company. We have several branches. The headquarters is located in Austria. Then we have our branches in Poland, Estonia, Switzerland, South America, and South Africa. Here you can see some of our clients. So yeah, you can trust me. If they do, you can trust me also. So we do everything connected with PostgreSQL. So the only demand to become our client is that you have PostgreSQL, and then we can help you with anything you want: training, consulting, support, performance tuning, everything. Yeah.
And let me add a word here. I especially appreciate the work you and your colleagues do blog posting, because articles are always like quite short and very informative, targeted to some practical use cases. I really like reading them, so it's great.
Thanks. Okay, so today's agenda, I hope we can do it quickly and funny. So first of all, I want to introduce you to the Go languages. Then I will discuss what tools and integrated development environments are available today. Then we can check what drivers can we use to work with the PostgreSQL. I will highlight some useful extensions that you can use in your everyday work. And then I will try to cover a little the testing, how we do testing with the database. So first of all, why Go? You may consider Go the young language, but it's not really. It was firstly released in 2007. The main idea behind Go is to produce the native binaries. So for each platform you support, you can produce one binary to pack everything into it and not to be dependent on the libraries or anything present or absent on the system. The other idea is simplicity. So the language itself is very simple. It has something like several, not many keywords that you can use. It has fast compilation. It has enhanced and standard library. The concurrency in Go is implemented using with the Go routines. So in fact, that's not a threads, but it parallel. It's a concurrency model where the language engine itself controls what and how to run. Yeah, since it's a pretty simple language, it's easy to learn, and right now we have a lot of comprehensive tools and libraries, so it's pretty straightforward if you want to start from the scratch. Here we have the survey results from the 2020. We have fresh results from the previous year, but I didn't update this picture because they slightly changed the questions, and I wanted to be this way. The main idea behind this picture is that half of developers working with the Go language somehow interacts with the databases, and most of them are doing web programming or something like that. This year is pretty much the same. Let me show you. So here are the results from this year, but they changed. They are using now some kind of RPC services and data processing, which is not the same as databases, etc. So I left the old picture to describe what the areas are mostly covered by the Go language. So what are the top products written in Go? Of course, it's a Kubernetes. Everybody knows Kubernetes. It's just like a trend. Yeah, everybody using it. Another one is probably Hugo. So it's a framework to build static websites. Who works already with the Go language knows Gin framework, Grafana, used for monitoring, observability, and visualization, etc. As well as the FRP is a fast reverse proxy, so you can expose your local servers behind a NAT or a firewall. Etcd, by the way, which is used in Patroni usually, the Kivala store, etc., etc. So a lot of applications already available written in Go. What about PostgreSQL related? Maybe the most famous is the both Postgres operators, one by Zalando and one by Crunchy. I'm not aware if we have another kind of operator. Probably, yeah, by time scale, but it's not open source yet, so let's see. WAL-G, which is the successor of Wally. Yeah, so right now WAL-G supports not only PostgreSQL but MySQL and MSSQL, if I'm correct. The PG Center, it's a top-like console admin tool for troubleshooting Postgres, for monitoring the Postgres. Another one is a PG Watch, written by the Cybertec, which is the monitoring solution for PostgreSQL. The PG Timetable, written by me and Cybertec, it's a scheduling solution for PostgreSQL. And the PG Flame, just a nice flame graph generator for explain. Give it a try. It's very fun. If you want to know what more do you have right now, right here, for Go language, just visit this repository on GitHub, Avellino, Awesome Go. There are a lot of everything, so they are just divided by the categories. Choose your fighter and check it out. Okay, so what tools and what integrated development environments are available right now for Go language? Again, these are the results from the 2 years ago, the results from the survey made on the go.dev blog. As you can see, the Visual Studio Code by Microsoft is a winner here. As for this year results, they are not really helpful, because this year results, you could answer the questions right from the Visual Studio Code. They did it. So okay, yeah, of course we have now 91% of users of VS Code, but yeah, they are just like stating that it's not the right way to measure. So when they just like remove some portion of the VS Code users, then we have 42 for VS Code, and for Golang 37, so, which is pretty much the same as for the previous years, right? So only maybe 2% are going for Golang. Other people are still using Vim, Emacs, and some of them even Sublime Text. Okay, what about
use?
Yes, what about me? My environment. Yeah. First, when I started, there was no Golang available. It was in a pre-release state alpha, or maybe earlier beta. So I was just like, okay, I will try it with the VS Code. I was not fond of it because VS Code is based on Electron, and Electron is a JavaScript thingy, and I'm just like, oh no, IDE in Electron, it will be slow and monstrous and whatever. But yeah, let's try. And I was really surprised. It works well. It doesn't have early stage problems anymore. So yeah, it's absolutely fine, and I may recommend if you want to try it. So VS Code is my IDE of choice. Then I installed this small utility Go test from Rekil. It's just it just colorized the output of Go test command with the colors. So for example, you can see errors in red and past test with green, etc. I will show you probably later. All of my projects are controlled by linters. For that, I'm using Golang CI lint. This is not the linter itself, but it's a tool which can run several linters of your choice against your code. There are, I don't know, 20 plus maybe linters available, but yeah, basics are 7 or 10, something like that. So they are running every commit against my code, and I do not push any things that are not compatible with the linters. It's forbidden. Yeah. Then I installed the Top 9. This is artificial intelligence code completion tool. It works well because depending on the project you are working on, it suggests you the most common the most frequently used codes or command or functions, etc. Then for producing binaries, we use Go Releaser, of course PostgreSQL because we're working with it, and the another service I discovered maybe a year ago. It's a Gitpod.io. It's a container-based and ready to go developer environment. I I will probably try to show it in action later, but in a couple of words, it allows you to run your development environment in your browser right away from any repository. Just like I did experiments with the PostgreSQL itself. For example, I want to try the latest commit of, I don't know, Peter Gigan, for example. To try it locally, I need to install the development, install the tools, download check out the sources, apply it, configure, make test. Not an easy task. But if you use Gitpod, you just like may run the environment from the Postgres repository, and in this fresh environment, you may configure and build and check if that works, and it's very cool.
It should be. I also looked at it, and it looks like it should be helpful for open source projects to make contributions easier for new contributors. Maybe
absolutely. Right? I will try to show how this how this can work on some projects in a couple of minutes. And also, I submitted a talk about developing Postgres using the Gitpod.io for the PGConf view. And my talk is on the reserve list, so I'm not yet scheduled, but if something will happen, I will present this talk. Hopefully, I will. Okay, so our projects are living in GitHub, but I suppose that GitLab is pretty much the same. So in GitHub, we are constantly running the Dependabot, which checks all the dependencies of our projects and automatically creating the pull requests with the updated libraries. The CodeQL runs analysis to find vulnerabilities. And then in every project, we have at least 3 more actions. The first one is build and test. Of course, after each commit, you want to be sure that your binary can be built and that all of your tests are fine. The release one is firing when we have a new tag on the repository. So it just like takes the source, producing the binaries, and publishes a release automatically. Then the only thing you need to do is just edit, add changelog, add texts or whatever, and you're done. And the last but not least is Docker, which, depending on the project, it may update the Docker again master, or it can update Docker again every tag is available or every release available in the repository. Okay, so now about PostgreSQL, about database. To speak to the database, one need to use drivers, right? The thing is, I'm strongly against the ORM. It's just like a holy war to me. we can make another talk about why people shouldn't use ORM. Yeah, even if you want to use it anyway, ORM need to use driver on the low level to speak to the database. That's why you anyway need to know what drivers or what libraries are available. So let's start. Okay, so in fact, the Go language standard library has database SQL package, which is in fact a set of database access interfaces. So these interfaces define what methods you have as a developer to work with the databases. And for each of the databases, there is one or several implementations. So if you want to use the standard database SQL library, you import it first, and then you import one of the implementations specifically for PostgreSQL. The standard de facto for many years was the libpq, which is the pure Go Postgres library. But the thing is that for year and a half, probably, or 2 years, it is already in a maintenance mode. So no new functionality arrives, only bug fixes, very rare, and it's a solid piece of software, frankly speaking, but there is a lack for specific PostgreSQL functionality. A year later, after the libpq released, JAX-C released the PGX library, which is the enhanced version of the PostgreSQL driver. And if someone starts, if someone is starting to create a project nowadays, probably PGX is the choice by default. The funny thing is that PGX can work in 2 modes. It can be compatible with database SQL by adding another layer, or it can be absolutely independent. You can use only PGX functionality, which is great. I will show you how to do that. So I do like compare the importance or of projects by comparing the stars they do have on GitHub. I know this is a shitty metric, frankly speaking, but we cannot compare the loads of the packages, for example, because the Go doesn't use the central repository, so just like npm or something like that. So we cannot measure what exactly download number for each of these libraries. And as you can see, the libpq is growing still, but PGX is growing faster. For me, I'm explaining this like if you want to start the Go career, right? You will find a lot of examples, a lot of articles about how to start with the libpq. You're going to the GitHub, oh, libpq, you start it, okay? Then you just like, okay, it's not enough. It's not enough. I need something special. And then you find PGX. Okay, PGX, you start PGX, but you already start libpq. And yeah, so that's why PGX still cannot catch the libpq, but I think it will be in a year, maybe something like that. Okay, so what the difference between the PGX library and the standard database SQL? When to use one and when to use another? The thing is, if you start a new project and you want it to work exactly or only with the PostgreSQL, and you are not dependent on other libraries which use the database SQL, or then you probably should go with the JAX-C PGX from the very beginning. If you are in a situation when you have already old application, or for example, you're using Gorm or SQLX, they are dependent on this database SQL library, then anyway, you should go with the PGX, but with the special layer called stdlib standard library, which is the middleware between the database SQL and the PGX implementation. Oops. Okay, so why PGX is so cool and why one should choose it instead of database SQL? Well, first of all, PGX supports natively all PostgreSQL built-in types, and it can support user types as well. It automatically prepares and caches all the statements. It supports binary format for all built-in types. It supports copy protocol immediately, and you can do copy protocol with the libpq, but that's really not an easy task, I would say. The PGX was built from the very beginning to support all, not all, maybe most of the loggers available in the Go world. It has connection pooler. It supports listen notify out of the box, and listen notify isn't supported by libpq, and automatic conversion of such data types as arrays or HStore or JSON or large objects, etc., etc. So yeah, there are a lot of features in PGX, and a lot more than libpq can provide. Okay, how the
1 second. What?
Yeah.
Simulated nested transactions with save points. Why simulated? Because like I thought save points is a nested transaction.
Yeah, I mean, I think that the meaning here is that simulated in nested transactions in Go language. So just like, yeah, in the world of Postgres, we know that we can use save points, release save points, right? And yeah, that's
and there is
how
nesting there from Postgres point of view. Oh, okay.
Yeah,
so
so just like in PGX, you can begin transaction, you get the object, right, of this transaction, and this transaction then has a method begin, and you have another object like a sub-transaction. In fact, we know this just like a save point, and in fact they are the same, but from the developer point of view, you're like dealing with the sub-transaction, sub-object of it. Okay, so how should the simplest application look like if you wanted to use the database SQL library, right? If you are dependent on SQLX or GORM or whatever, just like I said, we first line we import the database SQL, and then in the last line we do silent import of the PGX standard lib, right? And then we do like described in many articles. So we are SQL open, the protocol called PGX. We are providing the connection string. Yeah, and then we just like working with it. What if you want to use the PGX solely without the database SQL? We just remove the database SQL from our import, and we leave only PGX in our import. And then we just can directly use PGX connect. The difference here, as you can see, is the PGX is supporting, PGX supports contexts. In the latest version of database SQL, you can use contexts, but it was not available maybe a year ago or something like that. So that was a great improvement at that time. So yeah, you just do connect. You're using context. You are providing the same connection string, and the methods are pretty much the same. So it's not like something new. Here, the difference between database SQL and PGX right here is that database SQL implements connection pool by default. Here, if we use PGX connect, we are creating only one single connection, and of course we cannot use it in parallel, like passing it to the several Go routines or something like that. But Go developers used to write their applications having in mind that you are going to work with the database connection pool, not a single connection. For that purpose, we can use PGX pool library of the PGX, which produces the pool of connection, and then with this pool, you can pass it to the coroutines. You can work with it in parallel. It will automatically start new connections, close old connection, etc., etc. You can acquire connection from the pool, do something specific, or I don't know, and then release this connection to pool, etc., etc. The drivers itself are pretty much the same. The difference is what useful extensions or what useful libraries can you use with them. All of my projects were started with the database SQL because of the JModern SQLX extension. It's very useful. It allows you to export raw from the result set immediately to the object of the Go language. For example, not executing these loops like going for each row, taking the values for each field, and put the properties of each structure, object, etc., etc. It allows you just to pass the pointer to the structure to the method, and this library will automatically fill all the properties. For example, just like for example, I have a place structure, right? I have a country which is string and can be and cannot be null, right? I have a city which can be null, and I have some kind of telephone code. Then in usual database SQL application, I should go through all rows and through all fields and assign all the values to the my properties. But with the SQLX, I just like row struct scan and pass the pointer to my structure, and it will have to automatically fill all the properties available from the query. And the same that was for a one row return, right? But if we have several lines, several rows in our result set, we just can automatically create the slice of structures. Just like here, we can get like one place structure, and if we have several, then we can select, and we will fill all the place structures into the slice. Well, it's the same works for simple types like integers or strings, or it's very handy and very fun to write just one line and you're done.
So it's very similar to ORM, but it doesn't run away of SQL.
Yeah,
from SQL.
I mean,
right?
When someone asks me what about ORM, and I just like, why do you need ORM? Maybe you just need a simple way of transforming result set to the objects in your application, and that's it. Maybe
less
that
code.
Yes, right. That would be enough. And yeah, in maybe half of the cases, this is the truth. So you need just an easy way to transform your result set into your application objects. Yeah, so for PGX, there was no such a library, and that was a showstopper for me. For example, I spent maybe 2 years on a database SQL, not on the pure PGX implementation, because I need these libraries. It's very easy to work with that. I didn't want to rewrite all my code. And later I found the Scanny, which is the parallel implementation of the same thing for PGX, it supports not only PGX but a database in SQL and one more, I don't remember right now, driver. Oops. So just like you do the same, you are defining the structure you want to use. Then you create pool or connection, and then you just like select from the result or from the query right away to the slice of the objects, and the same works for basic data types and basic variables. Now, as I said, I'm not fond of the ORM, because I think that's way different from the relational databases. But on the PG Day Switzerland recently, a month ago, I was talking with the author of the Java library Juke, JOOQ. Yes, and we had a really great time, because before this talk I didn't realize the concept of this particular libraries or components, right? And I was just well, let me explain what the Juke is. So okay, we have, for example, we have a two-way, yes, ORM or native drivers. The ease of ORM is that you have right away everything you need. But in case if you want to go with the SQL, you will probably give a lot of performance. You know what you do, but it's not that maintainable anymore, because every SQL is just a string. And for example, if you change your schema or in your database, you need to change every SQL you have, because otherwise it will fail, right? And the third solution would be to have a SQL builder, which will know your schema and will transform it into the objects of your language, and later you can use it instead of SQL. So it looks like this, for example. So in fact, you're writing the SQL, you're writing select statement, you're listing all columns you need, then you're listing the sources like tables, joins, whatever. You are applying where clause, group by, etc., order, etc., etc. But the thing is that here, if you change the schema and trying to run your application or test, it will fail immediately, because the objects generated from your new schema are not anymore valid, and the compiler itself will tell you, no, we don't have, for example, this table anymore, or we don't have this column, or it changed. So it will change the data types of column, it will change everything. So you cannot even build it if you change the schema. And that's a real use case. That's really cool, I would say. I'm not yet into it. I'm still using the strings in my project, but the idea is very attractive, very attractive. So one of the libraries that's available for Golang is GoJet. So it's a SQL builder for your schema. So as it supports a lot of databases, not only PostgreSQL. So like I said, you just you have your schema, then from it's not a norm. You see, it's saying it's not a norm. So from the schema you generate objects of your database, of your schema. For example, right now it supports select, insert, update, delete, log with statements. So not many, but for others you can use probably raw string representation. It's okay. And okay, so it generates your schema, and then in your project you will have your tables, you will have your views, models, etc., etc. So when you start to write your code, your compiler knows exactly how your schema looks like. So you can use code completion, for example, which you cannot use if you write right now when I'm working with the SQL. I first do it in the PSQL or dbeaver or whatever I have, right? I debug everything, then I put that string into my application, right? Here you don't need this. You have it from the beginning. The IDE can suggest you the table names or column names. It can suggest you the operator that is applicable to this data type, so etc., etc. It looks fun, and probably I will try somewhen this
Yeah,
approach.
but I have a question. Like I
Yeah.
didn't understand the like very important part. How this schema. So compiler, you say compiler understands knows about the schema, but Postgres connection needed for that, or it's like some
Okay,
net
yeah.
information
So
stored in files.
the first thing is you are creating the schema on the taste database, right? Then you are using Jet application or Jet console application, and you generate the Go files from your
I see.
PostgreSQL schema, and then it's generating tables, views, types, etc., 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 and then it creates this generated tree with all of the files in your project. So every time you change your schema, you should regenerate your Go application or your Go files, and then you can use them in your sources. Of course, I must say that one shouldn't manually edit all these files. They are just like need to be regenerated automatically. It's of course up to you how you will do this. Another solution for that will be SQL C. This will also generate type-safe Go language code. SQL C stands for C compiler, but it's quite different. If Jet is trying to generate all of your objects and allow you to use them in your code, SQL C say, okay, let's playground open blah. SQL C says no, just give me the tables and give me the queries you want to run, and I will generate methods of these queries. So for example, here we have table authors, right? And then we say that we want to have method get author, which will return one row. Then we want to have method list authors, which will return several rows. Then we want to have procedure or method create author, etc., etc. After that, after you fill this query, you of course need to run the don't remember how, SQLC probably, console utility, and it will generate the three files. The first one will be the interface that you will use later in your application. The drawback is here is that SQLC works only with database SQL package. So if you want to use the raw PGX, you are somehow limited. But anyway, so here we have in models Go, we will have the definition of our table or tables or views, which we will put here. And in query SQL Go, we will have all methods that will be generated according to our SQL and our meta comments here. I'm not sure. I'm just like, well, yeah, interesting idea. I just need to try it in the real project, how can it work. But frankly speaking, I'm more like into the go-jet approach. So yeah, we'll see.
But these both approaches, they don't think about migration process. So you need to regenerate everything, and then probably in Git you'll see some minimal diff, but maybe not, because the order may change, right?
Well,
So
yeah.
the
Probably
evolution.
one can just like ignore these generated files into Git. If you can regenerate them on each build, maybe you can just don't put it into the repository. But yeah, something like that. Okay, so that was about the drivers and solutions available, not ORMs. And what about testing? So okay, the testing databases is not simple stuff, because we are divided into the client application and the database itself, right? So the first approach would be to test against the real PostgreSQL server. Many of us do this. The solution would be just like start or create the fresh database, fill the schema, then run your tests, then drop the database, and every time you need to repeat these steps, right? It's not an easy. Another solution would be to use mocking libraries. I will show how it works. Right now, I want to say that for database SQL, there is well-known Go SQL mock solution. And again, there was no mocking library for PJX, and one needed to write it. And guess who did it? Yes, I did PJX mock. I wrote PJX mock, which is the pretty much the same implementation as a SQL mock, but for PJX for it methods in interfaces. I will show how can we work with the mocking libraries. And another way to mock not the PostgreSQL itself, but mock the wire protocol of PostgreSQL, right? For example, I will start with the Cockroach Go test server. Cockroach, as you know, is a database. It speaks PostgreSQL language. That allows you use a Cockroach as a test server in your application, because your application will never know if it speaks to the real PostgreSQL or Cockroach, right? And the Cockroach Go test server is a package which runs during the test instance of the Cockroach DB, and you can run test against it. So on the first run, it will download the Cockroach server binary into your system. And on the next run, it will find it cached and will run it from your disk. So it will much faster. If you want to test really hard, you can use the JAXC pgmock library. This way you really can just emulate the PostgreSQL native protocol, like sending packages and replies and whatever. For example, with this approach, you can somehow send run packets or malformed, and we'll see how your application will deal with that. Very fun, but they're very cumbersome. And one more approach from CockroachDB is the copyist. The idea is that first you run your tests against the real database, real PostgreSQL server, and the copyist will record this session. And after that, you will run it again and again, but it will not talk to the PostgreSQL anymore. It will replay the session. It will replay the answers from the previous recorded session, from the previous calls, and will answer to the application, to the calls that way.
It's like cache for queries, like the same. If query is
something
same,
like that,
then answer
yeah.
Interesting. Why would we need this?
Well, sometimes you don't want to run a real server in your test environment. Sometimes you have.
Why? Because to save time, or why? Like,
for example, if you want to run the test in GitLab or GitHub, there is not always a solution to run a PostgreSQL in these actions.
Okay.
Yeah.
I thought it's only about timing, just not to spend time.
Yeah, timing is really important. Yeah, but it's the PostgreSQL itself is not always available. And sometimes, for example, if you're using pgmock, sometimes you can make packets look wrong, right? And to see how your application deal with it. Or if you're using mocking library, you can pretend that the answer was not that the real Postgres will. For example, you want to emulate the error, like connection dropped. How you will do in the real PostgreSQL? You need to erase some kind of error or
Determinate backend.
Yeah, just like that. And if you're using mocking library, just like, okay, we have an answer that the connection is dropped. What will it do? Okay, so
well, a reason I'm asking, I'm not going to steal agenda, but the same way you hate ORM, I hate mocking approach. I hate all mocking approach. I like only real testing, and to speed up real database testing, we are building the tool Database Lab Engine, which provides thin Postgres clones. So one server, dozens of clones, and they are launched in a couple of seconds. So like mocking not needed anymore. But I understand, like sometimes some people can choose mocking still.
Well, I would say that, yeah, I agree. In my project, I'm trying to use both. So part of my tests are running against mocked libraries, and part of my tests are running against live server. Yeah, because but the mocking helps you to test just like one function. You're not dependent on schema deployed or something.
It's like unit testing, right?
Oh yes,
similar
of course.
To unit.
Yes, of course.
Very small part of everything.
Absolutely. Okay, so let's try. So here is the repository for pgxmock, and I will try to run git pod io on my repository, just to show how you can run your environment from your browser. Just like imagine you're sitting on the beach having fun, beer, and you're just like, oh, I want to test something, and the only thing you have is just like an old laptop or a tablet, right? Just a couple of seconds, and we have a working environment, right? This is a VS Code, and here we have our files. And as you can see, the gitpod adds a gitpod YAML file automatically. You can add it on your own to your repository to tell the gitbot what kind of actions you want to be done before the environment starts or whatever. So here we have just like go get, so we get all sources and dependencies, then we go build, go test, and then go run. So if we would have some kind of application here in our repository, when we open, it should be run right away, so providing some kind of, I don't know, functionality. Okay, so let's see basic example of mocking, how one can mock. So here the code, right? Here the code we want to test. So I say I want to use pgx, right? And instead of passing the database structure, the database pgx object into my functions, right? I want to pass the interface. Why is that? Because later I want to mock that interface and change the real database connection to my mocked connection, right? So this this function will just like accept user ID and product ID, and we'll try to update products, and we'll try to insert some product viewers, and then if everything fine, it will commit, and else it will roll back, right? Nothing complicated. So in the main function, we see that we are using like real one, pgx connect, right? And etc. etc. How can we test it? Let's check the basic test. So I always start from the successful cases. I'm a positive guy. So first of all, I want to create a mocking object. So pgx mocks new connection, right? And then we are trying to explain to our mocking library what we are expecting from our function, which will be tested, right? So I'm saying that I'm expecting that my function will begin the transaction. Then inside this transaction, I expect it will try to update something, update products, for example. And okay, so I expect it will return one row, so it's okay, it's success. Then I expect that after that we will insert something into product viewers, and the arguments will be 2 and 3, for example, right? And we will return the result that inserted one row, right? And then I expect we should commit the transaction, and that will be a successful scenario. Yeah, let's try that. So I'm calling my record stats function from here, which we are trying to test, and I will pass my mocking library to it, and I'm passing the 2 and 3 arguments as a parameters line, right? And if this test fails, I will get error that something's wrong, right? The cool thing here is we can explicitly say to the mocking library that we are expecting these commands in that specific order, right? First of all, we can check if all expectations were met. So okay, so did we start transaction? Did we execute insert and update? Did we execute commit, etc., etc. And also we can state that the property of the mocking engine of mocking structure is we want to check that every command we send, every command we test is in that specific order. So for example, there is no insert and then update, that will fail. We want to update and then insert, right? But sometimes it's okay if it's in unordered. For example, you just running 2 Go routines simultaneously, and you never know what will be the first update or insert, right? So sometimes it's okay to have unordered expectations. Yeah, so another one will be to check for a failing test case. So if we were testing the positive output, we will not test this as if error, not a nil. We only test the positive workflow. And for a failing test case, we need to emulate the error. For example, here we are starting the same. So let's start a transaction. We are waiting for update, and we are waiting for insert, and we are waiting for it to be with the arguments 2 and 3. But we are telling our mocking library, instead of returning okay, the command was successful, please return error. So our function can somehow react to that, right? And if we produced error, then our function should do rollback, and we are waiting for and we are expecting for this rollback. And yes, then we are running our record starts again with the same arguments, and in this case we are waiting for error. So if there is no error, something won't happen, because this is a failing test case. And again, then we are waiting for expectations, etc., etc. Yeah, so let's try to go test. Okay. So can you see, maybe I should make it bigger. This is a console.
I see it quite well. So
okay.
all letters are.
Okay, so go test verbose. Let's try all tests. Yeah, so that's not only these two methods, but all of the repositories. So if I want to run all of this, we should go to the examples basic. Yeah, and try to run it again. Okay, so here we have we run one, we pass. Okay, so as I told you, I'm using like this kind of go test. Oops, sorry. I stopped sharing my screen.
Yeah, it stopped.
Sorry.
Start
Okay.
now.
Okay. So as I said, I'm using the go test for colorizing my test output, right? So let's see how it different now. So that was the black and white, and now it's white and green, right? And for example, if I want to show you T error, for example, I'm tired, right? I want to show you the error. And we have an error. So you can see it. And for example, if we are working from the root of the repository where a lot of test cases, and we are running just like go test verbose and all of this. Why is that? How about this? Okay, so now we have a lot of tests. The idea is that all tests, not all, but most tests in Go language are run in parallel. For example, we can see that many tests were started simultaneously, like in parallel, and then later we have one error, and it's very hard to find it in the black and white screen, you know, with the eyes. You know there's error, and you try and oh shit, control find error, and here we have okay, I see it. Test should update states, basic text, line 28, I'm tired. Yeah, I see you. Okay, let's try to fix it. And yeah, and we are fine. Oops. So that was the demonstration of how you can start immediately the environment, new development environment with a Git pod. It's free for open source. I do like that very much. Like, and you can even start.
It's like workspace as a code, right?
Yes, exactly. It is, but it is free for open source. If you have a public repository, you have a 50 hours of these development of the machine time of these environments per month. It's more than enough. Well, frankly speaking, if you work on your project, you're working locally with your IDE setup the proper way. But if you want to try to something new or new language or new library or whatever, or if you want to share the screen immediately, like you can use that, and that's very cool. That's very cool. Okay, so I showed you. So takeaways. Yeah, Go language is popular. It's easy. It's cool. It was #1 most in demand languages by the survey by Hired a year ago, probably. So the half of all developers of Go are working with the database one way or another. You can use your preferred IDE, or you can even use your browser to work with Go language. Go is here to stay because Kubernetes is completely based on Go, and every operator is written in Go. I don't think we will get rid of the operators in Kubernetes in the near future. Yeah, so it's flexible. You can use the connection library of your choice, but I would go, and I suggest to go with the PGX. It has a lot of integration with the GitLab, and the main feature of Go is it is backward compatible. So written once will work forever. That's not the case with the Python, for example. The switch between second and third major version was a pain. Not only for Python, but for PostgreSQL as well. We had a long time of the Python 2 support, and probably in the 14 it was dropped, or if 15, right? Python 2 is dropped.
I don't remember, unfortunately.
Yeah, but the idea is.
Yeah, speaking of Python. Oh, okay. So sorry. I will ask a question later.
No, you can go.
Yeah.
Probably.
So yeah, speaking of Python, there is PL Python, and we still have a bunch of PL language like PL V8. It's not language, but it's JavaScript, right? And PL Perl in the past was popular. There were attempts to have PL Ruby, PL Java, and so on. But what do you think about like why these in this Postgres is very flexible, extensible, and so on. And in this area, it was like a good idea to take some language and bring it inside Postgres itself. What do you think about the idea of having PL Go maybe, and maybe like if it's not working, also why?
The thing is that since Go compiles into the binary, so it's the same as a C. You don't need to have a separate procedural languages, and there are projects. First is writing extensions on Go as a background workers, and the second is writing libraries on Go. They do depend on the C compiler. That's not a good dependency since the religion of Go to be platform independent. Like if I want to build a binary for several platforms, I did it on my source platform for several times for different targets. And if you want to build an extension or a library for PostgreSQL, you probably will need to use some kind of cross-compiling for C, because you need to compile those headers to be used from the Go binary.
So you think it does make sense to have PL Go, but it makes sense to create extensions using Go sometimes, right?
Yes, I haven't plans to create extensions as a background worker, but as usual, I have not so much time. But the idea is here, and I still keep this issue in my repository to remember that I will need sometime. I will need to try that.
And another question I have also, of course, like what do you think about the idea to have something related to migrations in these libraries? Or like, I mean, ORM is bad, I agree, because it hides SQL. It should not hide SQL, but many ORM advanced so well, like for example, Ruby on Rails and others, they offer something good in terms of how migrations should be made. And like this is a big problem around migrations, you know, like how to track them, how to make them zero downtime, and so on. And what do you think about this? Like, is there any opportunity for these libraries to grow and to improve the experience in these areas?
I do like to control migrations by myself. For that,
because there are no good tools, that's why.
Well, yes, DBMate. Okay, dbmate is the famous, I would say, tool. It's written in Go, so one can probably use the source of this.
I saw it.
Yeah, but frankly speaking, I implemented my own in my.
You don't use this one, right?
No, I use my own because usually I don't need the whole functionality of such a libraries. I need narrow one, and I know better how to do it.
Exactly. These ORM parts, they are good. They provide something, but if your database is big and heavily loaded, none of them provide good capabilities for zero downtime migrations.
I think with ORM, you are fine if you are going with code, with the approach code first, right? If you apply
because it will generate something that will put your database down always. You need to rethink and rethink and extend and so on. So I think there are challenges that are not yet like covered here.
Yeah,
this is good tool. I remember it, but still it's far from being like zero downtime fashion. Actually, I'm criticizing them, but I should criticize Postgres documentation first. For example, we have create index concurrently, but we don't have alter table implemented and purely like there are no recipes inside documentation, so it's a bigger problem, not related to libraries or ORMs.
Yeah, I think that the migration will be another talk, not even somehow dependent on the Go or other platform or language you're using.
But I'm interested, like, what do you do if you want to control it yourself? How like you approach some complex migration, big database under load? What do you do?
So my application controls the schema version. So when I start my application, it first controls the status of the schema, the version of the database. Then, if it's allowed by user or by start options or arguments, it will apply the migration, and then will start in the main loop. If it's not allowed, like do this silently, then it will just like say to the user, hey, to operate, I need to upgrade this, I need to apply these migrations, that, and that. If it's fine for you, just like rerun the application with the argument like update, something like that.
And you write all the SQL code for migration, DDL and so on yourself always, right? Understanding what will work, what will not work, right? I mean, in terms of exclusive locks that last like 10 minutes, for example.
Let me show you where. So migrator, this is migrator implemented, but the migration are just like this. So there are just like, I don't know, that's simple enough. Maybe that. Okay, so I have a bunch of migrations. They are just like numbered by the issue or pull request number, right?
So it's interesting, like just to remind the context here. This is PG timetable you develop. It's a separate project, which is like cron-like tool,
cron-like, right? Scheduler,
right, with advanced capabilities, and you like if there are many users, and if we change something, we should consider some users may have a lot of data there and under load and so on. So we should be careful.
Yeah. So the thing is, if there are some sessions against our database, for example, we have 5 or more clients running right now, and we are starting our new application, which needs a new database, a new schema, it will say, hey, come on, I cannot do this because I have other sessions. Either drop them, or I can say them to stop, right? So I need an exclusive connection to the database to apply migrations, and later we can start. So that's how we are doing right now. I don't really think it's possible in automatic way without reloading the application, because anyway you need to start a new application, new code base, right? I'm not fond of running several versions of applications against the database.
Well, in your case, yes, but sometimes if you have 1,000 application nodes, and you have also like a green and blue deployments, A/B testing, and so on, you should think about running multiple application versions with one database. So that's okay. But in this case, you have better control over things, so you can do. Okay, interesting. But this table, for example, you use default 0 here. Before Postgres 11, it would last very long if table is big, right?
Yes, exactly. But the execution log is wiped every session, so we are fine.
Okay. So in this case, we are fine. Okay.
It's by the way, execution log. It's probably even not. Oh my God, I forgot.
Not real table. I mean,
like it's a table. It's not
unlocked.
Unlocked. Yes, exactly.
Unlocked table.
Yes. Yes, exactly.
I see. Okay. And probably Postgres version is already good, so there's no problem.
Yeah, okay. I hope.
I see. Do you test somehow, like on big setups, or like these changes you do, or you trust your experience?
Yeah, I have test cases for migrations. So beginning with the first version of my schema, I have a special test case where I just create the old one, the first one version of my schema, and then applying every migration we have one by one.
Whole evolution.
Yes, exactly. Of course, I believe there are some maybe situations where we can
have some long-lasting exclusive log, for example. Yeah. It's okay. I see. Well, it's interesting topic, especially to me, but I'm probably dragging our discussion to different area. But
no problem.
Okay. Anyway, good. Thank you so much. I learned something new, definitely. Thank you. It was interesting. I hope our viewers, most of them are watching. First of all, most of them are watching recorded. It's okay. But some of them are watching not subscribed, and this is not okay. So everyone should subscribe to our channel and comment, like, and so on. Thank you, Pavlo, for a great talk. It was interesting. Useful,
thanks for having me. Thank you.
Yeah, I hope we will meet somewhere in person one day again.
You should come to PG conference in Berlin, in Europe, this October.
I'm actually planning. I already accepted my acceptance letter. I need to accept it. Talking about database forking, branching. So probably I will come. Since if everything will be all okay with my visa as well. So, but if you're planning, I hope we will meet there.
Yeah, sure.
So, okay, great. Thank you so much.
Thank you.
Everyone, please like, subscribe, and comment, and share your ideas.
Like, subscribe, push the bell.
Yes.
Yeah.
Bye.
Bye.